to do that. Okay, wait, no, I can summarize. The existential necessity of expansion is the prime axiom. So there's no starting conditions. It starts from perfect symmetry. And it proves that the only physical transformation that can occur in perfect symmetry is expansion. And conveniently, when expansion occurs, you get differentiation because you end up with changes in the field, right? You end up with what we would perceive as density changes. Okay. So that's the existential necessity of expansion. So we know the universe is expanding. What happens inevitably when a uniform material expands uniformly is it pops into a new configuration, right? And you get an inclusion. And so we can think of that as a reference point because if we have no internal, when we do our first one, we have no external frame of reference, right? And so we're just like, okay, well, we have this point here. What's the difference between the outside? Well, we don't know. We don't really have any language or anything. There's nothing to compare it to, but we know it's different. So there has to be a density difference. So we've introduced some sort of gradient of density here. And also we have to, there has this separation from the background to this inside. Like there's this spherical symmetry, right? Or this spherical force, right? From this broken symmetry. And it is sort of a spherical symmetry though. Okay. So that's the first one. This is one dimension, by the way. 1 point is one dimension. Because you have to be, to be separate from the background, you have to be dimensional. Even though we can't say you have volume, we can say, even though we can't say how much volume you have, because you don't have anything to compare it to, we can say that you have volume, right? Because our state of perfect symmetry was still the whole universe. It was just backed up to before there was any differentiation. So the potential is there. There is density, there's volume. It's all there. We just can't tell yet. Anyway. Point was, okay, so we have volume in this first one, and we have this fundamental force that has a spherical force, right? This feels gravitational at this point, okay? So now we expand more, and then we get a second one. And when the second one, ouch, this is the problem. The second one, well, we don't have anything to compare it to, so what we're just looking for is the same difference as the first one. We're establishing our scale seat, right? We're looking for a second version of what we just saw, and then we will inevitably find one, and then we'll have two reference points now. Now, each reference point, we still don't have an external frame of reference, but we do know now that they are both the same size. Like, each one knows that it is the size of the other one, and it understands that it's not size of the background, right? But they can't really know how far away they are from each other. There's some Planck scale stuff in here that you get, some like quantum mechanics-y stuff. So now that we have that second one, we have a line, right? But importantly, it's not like a line that goes off in infinity, right? If you take one of the spots and then I take the other spot, and then we look around, we would see nothing. We wouldn't see like a reflection of ourselves, right? If I looked at you, I would see you. If you looked at me, you would see me. But it wouldn't be like you would be a vanishing point. I mean, since there's no distance, it still seems like, even though I couldn't tell how far away you are, if you're a reasonable distance, it's still going to seem like, you know, if you're 6, you're not going to be like a vanishing point if you're 6 feet away from me, even if there is no distance, right? So, okay, so we have two things. This is what it feels like to embody them. Let me see. This is 2 dimensions. Right now we have a line. So now let's introduce a third one. So now we have like a polygon, right? But now critically, we have to pay attention to what these things are doing inside our perfect symmetry, because they don't know that they're different. In fact, they all know they're the same, but they are all looking at things a little differently. Now, at this point, they all have the same perspective, right? Each one is looking at the other two. And as far as we're concerned, even though we aren't supposed to have an outside frame of reference, they all look the same to us as reference points. Within themselves, they may not feel the same. We don't know that. We can't know that. We cannot perceive them below this fundamental scale seat that we're acknowledging is the basis of our resolution, okay? So we did 3 of them, right? It's useful. It's fine. We have a shape. Cool. When we get 4, something really important happens. This is our tetrahedron. This is volume. So now we have like pow, pow, like a pyramid, right? And this can model the outside, because the outside, our volume, our initial volume didn't have an external frame of reference. So to say it wasn't a tetrahedron would be inaccurate, because we could not say what shape it was or wasn't. We could simply say that it was both infinite and finite. And then once we had our spherical inclusion, then it was only just infinite, because the spherical inclusion is finite, right? The cavitations, the prills, it's important. These can be called prills. Okay, so now, that was our 4th one. That was the first time we can model things. So that's important. Some people might say that this is the birth of intelligence or perception, and I think that might be a fair thing to say, right? Okay, so now let's add a fifth one though. This is where it gets interesting, right? Because now that we have a fifth one, we have this idea that we can model the outside with 4 parameters, okay? And then we have to take a fifth parameter that became a reference point to that, right? This is starting to feel like projective geometry now, even though I'm sort of a dimensionality out of it, right? But it's important to recognize that, like, if I was in this universe, now I would have enough points to mess with. So if I was a point, I would then be able to take these other 4 points and consider them and how they were like the rest of the universe, or what I could perceive of it, right? And that seems like it's useful. It seems to me that 5 points gets us consciousness, maybe even agency, I think. Honestly, I think agency is kind of, consciousness are kind of always there, but I think it's very clear here. Then, let's see. Oh, the 6th point. This is actually the last one that I think we need. The 6th point is, that's like, okay, now I can envision myself thinking about a model. So there's, the 6th point is what we require for self-awareness. And I think that there is an implication then that at whatever scale we're considering, we're going to see intelligence arise at a certain point, but not necessarily right at the beginning. Although I'm not fully convinced that's true, but I think in the way that we normally consider it, that would be true. Having said that, this is how I define intelligence, right? This is why people are not more intelligent than each other, right? No one is, like, so genius is fiction, okay? Intelligence is absolute. You either are or you are not intelligent. And the other thing is intelligence is absolutely everywhere. Genius is fiction, intelligence is absolute, and absolutely everywhere. It makes me feel good to